find the sum of a series. A series is just going to be some parts of a sequence added together. So this is sort of a partial series here, okay? Where my sequence is a geometric one that you've seen in the previous video. So if I was to do the sum of a series, let's think about, I don't know, the first 3 terms, and then we'll skip a few, and then let's talk about the last part and the part before. Okay, so what's the first term going to be in a series? Sorry, in a series or in a sequence. It's going to be A, and then it's AR, and then it's AR squared, because you're just multiplying by R each time. Okay, you might notice some early patterns here that compared to the top, this expression here at the bottom is playing catch up. It's always 1 behind. So I'm going to go ahead and say that over here, this will look something like this, because it's always 1 less. Okay, you increase by 1, you increase by 1. So if I wanted to find the sum, and I'm going to use this notation here, the sum of n terms, well, that would be all of these parts added together, wouldn't it? So how can we use this to come up with a formula for adding up all the terms in a geometric series very quickly? So we're going to do a trick. The trick is, underneath, we're going to have the same thing again, but we're just going to multiply everything by R. Okay? We'll see why this is in a moment. So A times R is AR. I'm going to write that over here. AR times R is going to be AR squared. Okay. A term will sort of appear, won't it? A term will appear over here. The AR to the n minus 3 will become AR to the n minus 2. This one will become AR to the n minus 1. This comes from law of indices. If you multiply by R, you're going to add the indices. So it will be this plus 1. Okay. And the last term is going to be AR to the n minus 1, n plus 1. And what can you do? Well, you can subtract one of these away from the other. Let's have a look at doing that. And it doesn't actually matter which way round you do it. Let's do RSN. So let's do the red one. Subtract the blue one. What would we get? Well, AR to the n doesn't have anything to take away from it. It's not going to cancel out with anything. It doesn't have like a partner. But then this one does have a partner. This one does have a partner. All these ones in between have partners. This has a partner. This has a partner. So what you're going to get is you're actually going to get just this. Okay? All of the stuff before is going to simplify to just this. And then we can factorize and play around with this. I'm going to factorize on the left here, and I'm going to factorize on the right. So if I take this big term here out, I'm left with R minus 1. And over here, I'm left with something like this. I'm almost there. What I want to do is get this one on its own. This means the sum of a geometric series. So I'm going to have all of this in the brackets over R minus 1. And this is one version of the rule. There is another version you can put in, and it comes from subtracting them in the opposite order, which works as well. But just to show you that this works, another way you can write this, if you take minus 1 out on the top, it will change the order there. And if you take minus 1 out on the bottom, okay, you will get an equivalent form as well. So if you know what your A is and your R is and your N, you can plug the numbers into this one. but you do need to know how to derive it, as it is a fairly common exam question. How do we do it?